Okay, so I just had to check my notes for a second there. There was something that I had miswritten, and not on what I gave you, but something that was going to happen. So let's do this. Let's actually take and find the Taylor series expansion for f of x equals 1 over square root of 1 minus x about x equals 1. Okay, so I'm going to consider this. Now, I can do this directly, or I can do this using the binomial theorem, which is what I want to show. Okay, so I'm going to do both. First, let's do it directly. Okay, so we're going to take the derivative f prime of x is equal to negative 1/2. Sorry, negative 1/2, 1 minus x to the negative 3/2 times negative 1. Okay, which I'm going to write that as 1/2, 1 minus x to the negative 3/2. Okay, f prime of 0 equals 1/2. All right, let's take one more. F double prime of 0, just to sort of do this, that's going to be negative 3/4, 1 minus x to the negative 5/2 times negative 1. Okay, so f double prime of 0 is going to be that's not what I want, but no, it will be fine. F double prime of 0 is going to be 3/4. Okay, let's do one more. F triple prime of x first. I should have written that there. So f triple prime of x is going to be 15 over 8, 1 minus x to the negative 7/2 times negative 1. F triple prime of 0 is going to be negative 15 over 8. Okay, so can I reduce that? No. Okay. I'm just checking that that's what I want. Yes, that'll work. Okay. So let's go ahead and write the Taylor series as f of x equals, so f of 0, or I'm sorry, f of, should be about x equals 0. Damn it. F of 0 is 1. So this is 1 plus 1/2 x. Just making sure I didn't get the minus sign. I know why. This should have been minus, so this becomes plus. Okay. Plus 3/4 x squared plus 15/8. Oh, I missed another term. I should also have a 1/2 here. Man. Why? I need my 1 over 2 factorial here, and I need my 1 over 6 factorial here, or 3 factorial here. Okay. Plus, extra terms. Okay. So this is the direct way. But you don't have to do this directly every time. Okay. Actually, anytime. We could also do this using the binomial coefficients. So and it is equivalent, okay? So using the binomial expansion is equivalent. So what we're going to do is we're going to say, okay, f of x is 1 over square root of 1 minus x. That's 1 minus x to the negative 1/2, okay? Or rather, 1 minus negative x to the r, where r is negative 1/2, okay? So, using the binomial expansion, this equals, 1 plus r choose 1x plus r choose 2x squared. Let's go one more. R choose 3x cubed. Okay. R choose 1. We know that's going to be r. Okay, that was from right here. R choose 2 is 1/2 r times r minus 1. R choose 3, same thing, it's going to be 1 over 6 r times r minus 1 times r minus 2. Okay, so let's plug those in and see what we get. So this equals 1. R is negative 1/2, so minus r. Oh. R is negative 1/2. Oh, plus, damn it. Something went wrong. Oh, no, it didn't. That is a negative x. Good. Okay, so this actually should be, these should all be, that should be minus. Those should be minuses when they're odd, right? Because this is negative x. And when it's squared, it's positive again. Now we're on the right track. Plus 1/2 x. The negative 1/2 with the negative x becomes plus 1/2. Plus r choose 2. 1/2 r is negative 1/2, negative 3/2 x squared. Minus, but with the negative x cubed, it's going to be plus 1/6 negative 1/2 negative 3/2 negative 5/2 x cubed. Plus other terms. Now let's put this all together one more time. Let me make this in orange. Equals 1 plus 1/2 x. Now, what do we got here? 1 times 3 is 3 over 2 to the third is 8. That is equivalent to that, right? 2 factorial is 2. Plus 1 times 1 times 3 times 5. It's going to be that's negative, sorry. It's with the negative x that becomes positive, okay? Hold on, so we've got, yes, that's negative x right now, so that's going to be negative, but then it's going to become positive. So 1, 2, 3, 4, negative becomes positive. 1 times 3 times 5 is 15 over 6 times 8. Here's our 6, 8, 15, x cubed. Same term, okay? So it's just another way to find these expansions. And this way is usually often what you see in books, okay? The reason is you know, engineers and physicists, they don't want to do Taylor series expansion. They much rather do this binomial expansion, okay? All right, I think that's it. I'll see you all in class.